For mission 1, I'll be talking about the Coriolis effect. Essentially, the Coriolis effect is the apparent deflection of moving objects caused by Earth's rotation. This would include air and water. Since Earth rotates from west to east once every 24 hours, this rotation is influential to how our air and water moves across the planet. Since different areas on our planet move at different speeds based on the latitude, it is directly a result of this rotation. For example, air closer to the equator moves much faster than air closer to the poles because it has a greater distance to travel in that same amount of time. However, areas closer to the poles tend to rotate more slowly. As air begins to move across Earth's surface, the difference in this speed causes it to deflect. So in the northern hemisphere, this motion deflects to the right, while in the southern hemisphere, it deflects to the left. The deflection explains why global wind patterns curve rather than moving straight, and is also why large storm systems rotate differently based off of the hemisphere in which it is in. The Coriolis effect is caused by the Earth's west to east rotation. Since the Earth has a spherical shape, the different latitudes move at different linear speeds, so the equator would move much faster than the poles. When air moves north or south, it retains the momentum from the latitude where it was originally. And as it travels over regions moving at different speeds, those velocity differences are what allow the deflection to be created. The air curves because the Earth is rotating underneath it, and is exactly why our northern hemisphere has that deflection to the right and why the southern hemisphere has that deflection to the left. So the Coriolis effect deflects atmospheric circulation across our globe, and it shapes how air is essentially across the entire planet. The deflection process works alongside pressure differences and the 3-cell circulation model, which includes the Hadley and polar cells, and they organize together to create the atmospheric motion that allows for predictable patterns to be created. So once warm air rises near the equator and moves poleward, the Coriolis effect causes it to curve, and this curve is what forms the major wind belts, which includes the trade winds, the westerlies, and the polar easterlies. It also happens to affect storm rotation. So in the northern hemisphere, air moving toward a low pressure center is deflected to the right, which causes hurricanes and cyclones to rotate counterclockwise. While in the southern hemisphere, air is deflected to the left, and this causes storms to rotate clockwise. And without the Coriolis effect, these winds would move directly from areas of high pressure to low pressure, and our atmosphere circulates